Hi friends, in this video we are going to do a daily challenge problem 2482, difference between ones and zeros in row and column. So this problem is marked as medium. Actually the logic is rather straightforward. So our goal is to introduce or practice this function, the zip function, right? So we are going to first digest the requirements and then we do the coding. So because the logic is so straightforward that we are going to do the coding directly after digesting the requirements. So here we are given a m by n binary matrix called grid, right? So a zero index m by n difference matrix diff is created with the following procedure. So we get the number of ones in the S row, the number of ones in the J's column, and the number of zeros in the S row, and the number of zeros in the J's column. Then the difference at index ij will be the ones in row I, column J, minus the zeros in row I and column J, right? So we want to return this difference matrix. So here you can see that this grid is bounded, m by n is bounded above by 10 to the power 5. In other words, we have at most 10 to the power 5 positions in this matrix. So with that said, we are ready to do the coding. So first I want to know that we want to observe observations. The first is that the sum of each row or the sum of a column actually corresponds to the number of ones in the row and the column, right, respectively. So if you want to count the number of ones in number of zeros in each row, so for example, the number of n zeros in a row, it equals the total elements in this row, that is the length of this row, but it's nothing but the number of columns, right? So the number of columns, so minus the sum of the row. In other words, the number of ones, right? Same for the columns, right? Zeros in the column. Let me write it like this. Respect column. It will be the number of columns, rows, right, minus the number of sum of the corresponding column. So that's our main observation. But here is how to effectively compute the sum of the columns, right? So we are going to use zip function. So if you you unpack the grid to the zip function, so you are going to get an iterable, which is an iterable for tuples. For example, this one, if you do this one, basically you get an iterable, so with the columns, so 0 1 0 0 1 0 and 1 0 0 and 1 1 1. So this way you can and do the sum easily, right? Now let's look at the coding. So here we have mn, so this m is the length of the grid, the n will be the length of the grid, so we pick one row, right? So in other words, n is the number of elements in a row, m is the number of column in number of elements in a column, right? That's also, we can interpret the m and n that way, right? So what we are going to return is something like this, right? So 0 times n for in range m, right? So now let's make a double for loop. So for I in range m and for j in range n. So we want to set the result ij, right? We know it should be the number of rows minus the ones plus the minus the zeros. First, let's get some information, right? So here we can see ones in row, right? It will be something like this. So we can sum an atom, sum row, see, for row in grid, right? So ones in column, so it will be sum column. So for column in zip grid. So notice that the length of this one, so this will be m, right? So the length will be n, right? So now we know that the number ones in ith row will be nothing but ones in row, which retrieve this one. Then plus ones in jth column, so this ones in column, that's j. Then minus the number of zeros in ith column. So this is the element in the column, that is n minus ones in row say I, right? And then we can do the same thing for the column, that is m, this is the elements elements in the column, so we minus the ones, right? Ones in column, let's see G, right? Then this will be the result, so you can do the return, right? So notice that you can do some algebra. So for example, this is ones in row, so here we minus ones in row, so we have two ones in rows minus n. So similarly, we have two ones in j's minus m, right? So basically it will be 2 times ones in row plus 2 times ones in column, then minus m and n. So let's first do a test. Grid is not, so here let's see, grid. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the cases. But here, let me make some comments. So here, the first comment is that you can copy this part and make some algebra, right? So I can comment out this one, and then I do 2 times this one, plus 2 times this one, then just minus m plus n, right? Or you can do 2 plus this one and this one, right? Let's test it. Yeah, this is one solution format. So here there's 2 steps. One is get the information for one's count, right? And then we prepare the return. So this is from solving the problem point of view, and an extension will be the following. So can you do this in place? With that said, basically that's about it for this video. Thank you.